Illustrative math geometry is called congruent triangles part 1. So our goal today is I can write a proof using rigid motions to show that all sides and angles are congruent of two congruent figures. So if triangle ABC is congruent to triangle A prime, B prime, C prime, what must be true? So go ahead, pause the video and try to come up with some things that must be true. I'm going to say here you're going to have 3 pairs of congruent angles and 3 pairs of congruent sides. So angle A is congruent to angle A prime. Angle B is congruent to angle B prime. Angle C is congruent to angle C prime. And then your sides, you're going to have AB is congruent to A prime, B prime. And then you're going to have BC is congruent to B prime, C prime. And then you're going to have AC is congruent to A prime, C prime. You could also say that there would have to be a sequence of rigid motions that takes ABC to A prime, B prime, C prime. Okay, so all of these things have to be true here. What could possibly be true? I don't know. We could say that both triangles are isosceles. Okay, we don't know. We don't have any markings, but it could be true. What else? We might only need one rigid motion, or we might only need 2 rigid motion. Okay, so when I say rigid motions, we're talking translate, rotate, reflect. Okay, so it just depends on the picture. You might need 3 rigid motions. Okay, so we might only need 3 rigid motions. So I'll copy that there and change that to 3. What definitely can't be true? We could say that the corresponding parts are unequal. We know that that cannot be true. They have to be equal. We could say we cannot have 2 different types of triangles, or ABC and A prime, B prime, C prime. Okay, like for instance, like scalene and equilateral. Okay, you can't have the original pre-image be scalene and then all of a sudden the image is equilateral. That can't be true. So all kinds of different things we could put there for possibly and can't be true. All right, so we're going to play a little game here called Invisible Triangle. So player 1, you're the transformer. You'll take the transformer card if we were in class. We'll just kind of do it together here. Player 2, you select a triangle card. Don't show it to anyone. Study the diagram to figure out which sides and which angles correspond. Tell player 1 what you figured out. Okay, so then you're going to tell them which sides and angles correspond. And then player 1, you're going to take notes so you know which ones correspond. And then you're going to try to think of a sequence of rigid motions without looking at the figures that could tell your partner to get one triangle to the other. Be specific in your language. The notes on your card will help you with this. So remember, I always recommend to do this. Translate to align a point. Rotate to align a side, and then reflect to align the entire figure. Now, you might not need to do all three of those, but generally speaking, if you follow that order, usually works, okay? So, and then you're going to listen to the transformer, and we're going to use the tracing paper to follow, okay? So here we go. So here's the first card. They tell us that these are the corresponding angles, and these are the corresponding sides. So here we go. So I'm going to write my directions right here. So obviously I'm going to say ABC is being translated to DEF. So I'll start with pick any one of these angles here that we know are congruent. So I'll say translate triangle ABC by directed line segment AD. We'll take A to D because we know they correspond. So now we got a point lined up. And then I'm going to say rotate A prime, B prime, C prime, either direction. I'll just say clockwise until A prime, B prime aligns with DE. Okay, because we know A is going to stay fixed because we lined A up with D. And then A, B, and DE correspond, or you can look over here, A, B, and DE. And then the final thing that we're going to do is we're going to reflect A double prime, B double prime, C double prime across DE is where we got it to line up, okay? And then these are all if necessary. You might not need to do some of these, so maybe I put if necessary for all of these. Okay, because like, you know, if I look there and an A is already lined up with D, then I guess I don't really need to do it. All right, so let's take a look here and see if that works. All right, so here are my two triangles. I'm going to trace one of them so that I can do my rigid motions. Oh, hang on, let me redo that. That was sloppy. All right, good enough. All right, so I'm going to translate by directed line segment AD. Oh, and then I'm done. I don't need to do the other one. So I started with that one, and then these ones were not necessary. So that's why I put if necessary. So I didn't have to do any rotations or anything. I just translated right there by directed line segment AD, and then the whole thing lined up. All right, here's another one. So kind of the same thing. Get one of these points to line up, get a side to line up, get rotate to get a side to line up, and then reflect to get a the whole figure to line up. All right, so I'm going to start with translate ABC by directed line segment. We'll go AD. We'll take A right to D, and then that's if necessary. Okay, if they're not already lined up. Rotate A prime, B prime, C prime, centered at A. Did I say that in the last one, centered at A? I didn't say that. Ah, shoot. Centered at A. I'm sorry, centered at D. Whoops. So centered at A prime, or I guess I could say D. Either direction is fine. I'll go clockwise until I got to pick a side that has A in it. So A, B, and D, E. So we'll say until A prime, B prime aligns with D, E. And then the last thing, again, that's if necessary. And the last thing is going to be reflect A double prime, B double prime, C double prime across DE. Okay. Let's see if it works. But I can use these corresponding parts to follow that sequence there where I translate, rotate, reflect. All right. Let me get this traced here. All right, so I'm going to translate by directed line segment AD. So right there. And then I rotate, so this will be my A prime, A prime, B prime, C prime. Rotate A prime, B prime, C prime centered at D clockwise until A prime, B prime, that'd be this side right here, lines with DE. No, I'm sorry, AB is right here. AB, A prime, B prime is this side, lines with DE. So here we go. I couldn't keep it centered at D just because of the way that this software works, but there we go. So, and I apologize for my my not very straight triangle. But there we go. It aligns. So I didn't need the third step. So there we go. Didn't need that one. All right, here's another one. I'm going to tell you what, I'm going to go back. I'm going to just copy all these directions. I'm going to change the letters, okay, to make things a little bit easier. So here we go. I'm going to put it right here. And then I'm going to see here. So A corresponds to D, so I can take A to D, or let's do B to E until, let's do B to E. So by direct line segment BE. Now I got B and E aligned. So we're going to rotate that centered at E this time until, let's see here. We know that B and E are aligned, so we need the one of the ones with B and E. So we'll say until either one of these, B, C, and EF align. So we'll go with B prime, C prime aligns with EF. And then we lined it up on EF, so the last name would be reflect across EF if necessary. Okay, let's see if it works. All right, here we go. All right, so I'm going to translate ABC by direct line segment BE. Rotate centered at E clockwise. Tell you what, I'm going to go counterclockwise. Well, I could go either way, clockwise or counterclockwise. It doesn't really matter. Would it be easier to go counterclockwise? But so I'm right there. So I think I end up with it right there. If you had tracing paper, it'd be a little bit easier, but I think that's where we end up, right there. And then reflect across EF. Oh, wait, hold on. Did I screw that up? Oh, wait, I wanted to align them this way. That's what I wanted. Actually, I guess it would have been easier to do counterclockwise. I have EF, yes. And that was BC. Yep, okay. And then I reflect across there, and that will take me right there to that triangle there, EDF. Okay, so you're starting to see you can do this if you know the corresponding parts by just following that translate, rotate, reflect pattern. All right, so do they coincide? So here's my statements here of congruency. Here's my picture. Here are the steps Noah had to tell Priya to do before all three vertices coincided. Translate triangle ABC by the directed line segment from A to D. So let's get this traced here. Translate triangle ABC by direct line segment from A to D. Rotate A prime, B prime, C prime using D as the center so that rays I don't like how they call them ray. I would call them segment, but whatever. A double prime, B prime, that's this side here, and DE line up, and this is my center, so I'm going to swing this triangle to the left there, and again, it won't let me keep that center in the same spot, so there it is, and then reflect across DE. That looks pretty good, all right? So when I reflect, I will end up right there. After those steps, the triangles will line up perfectly. Now Noah and Priya are working on explaining why their steps worked, and they need some help. Answer their questions, okay? So here we go. First, we translate triangle ABC by the directed line segment from A to D. Point A prime will coincide with D because we defined our transformation that way. Then rotate the image, triangle A prime, B prime, C prime, by angle B prime, DE, so that rays A double prime, B double prime, and DE line up. We know that rays A double prime, B double prime, and DE line up because we said they had to, but why do points B double prime and E have to be in the exact same place? So here's what I said. I said A, B, and DE are the same length. So A, B, and D are the same length. It's marked on the diagram. A translation and a rotation will not change segment length. So they will have to be in the exact same place. Okay. So if you get one point that corresponds to line up and then you rotate, the other one will have to be the same length because it's essentially a radius around a circle, no matter where you swing it. Okay. Finally, reflect triangle A double prime, B double prime, C prime across DE. That's what we have here. How do we know the image of ray? And again, I think that should be segment. A double prime, C double prime, and segment DF will line up. How do we know that the image of point C prime and point F will line up exactly? So we know AC and DF are the same length. So here's AC, here's DF. When we translate, rotate, and reflect, A triple prime, C triple prime, and DF will line up because we used all rigid motions. They are equal distance from the line of reflection, and on the perpendicular line, I don't know why I put A, on the perpendicular line to DE. Angles do not change when doing rigid motion, okay? So this, when I reflect over here, will match up with DE, and same up here with this I guess that would be, which one would that be? That would be B triple prime, C triple prime. We'll line up with EF. Okay. All right, so just a quick review here. Corresponding sides, corresponding angles, and a congruent statement. So, if I have all 6 pieces of corresponding parts, so I have 1, 2, 3 pairs of congruent sides, 4, 5, 6. I have 3 more pairs of congruent angles for a total of 6 congruent parts. We can write this congruent statement right here, and that we could dissect all those parts from just that statement. Okay? So I can explain why. If all the corresponding sides and angles of 2 triangles are congruent, then the triangles are congruent. So rigid motions there, okay, they should always translate, rotate, reflect in that order. I mean, I guess you could do it in any order. I just think it's easiest to do it in that order. They should always match up, map one onto the other. All right, last thing here. We got 2 triangles here. They tell us some things are congruent. What rigid transformation will take triangle GBC onto triangle ABC? And I would say reflect triangle GBC cross line BC. And again, you see how these angles are marked congruent? We know that when we reflect, the original angle and the outcome angle will be congruent. So we know it's a reflection. Explain why G prime will coincide with A. Again, reflections preserve angle measure, so G prime will be at A. Since angles A, B, C, and G, B, C are congruent as they're marked there, and AB and GB are the same distance from B. Okay, so these are the same angle, and these are the same distance from B, so we know it's going to go up there. Okay. Is triangle GBC congruent to triangle ABC? Explain your reasoning. Yes, there is a sequence of rigid motions that maps triangle GBC onto ABC, which we just used reflection. Okay. And I think that's it. So hopefully you enjoyed this video. Thanks for watching, and we'll see you next time.